All right. It is 1:50. So good afternoon, everyone. Hope you had a good lunch. Because now you're in for a treat. You're going to hear from 6 of the 7 alert brokers for Rubin. You're also going to hear about the specialized solar system broker, but not until Friday, but from David Trilling. But today we're going to, on this session, hear from 6 different alert brokers that have been serving up ZTF and now Rubin data. So yeah, I mean, to me, it is quite the accomplishment that these brokers are ready and working and starting to do enable great science. So let's enjoy the session. And our first speaker is going to be Monica Soraisam on ANTARES.
Okay, thanks, Mansi. So in this talk, I'll give a very brief overview of ANTARES and do a live demo. Hope it works. All right, so as you all know, ANTARES is one of the 7 selected brokers receiving the full alert stream from Rubin. ANTARES will also be hosting the internal alert filtering service for Rubin. And this is an effort of the community science team of Rubin, and Ryan Lau was leading it when he was at NOAA Lab. So ANTARES has been built with modern industry standard technologies and is deployed on the Google Cloud platform. Its complex internal system is shown in this chart, but for the end users, we don't really need to understand the underlying technology, but instead interact with simpler interfaces, which I'll go into in subsequent slides. All right. So as Mansi mentioned, ANTARES has been actively processing jointly both Rubin and ZTF alerts. It's also ingesting LVK sky maps at the same time, by the way. So the infrastructure is in place to ingest alert from any survey. As a matter of fact, I was able to confirm with Tom Matheson, who is the time domain lead of NOAA Lab, that ANTARES will ingest Roman alerts. So something to look forward to. Processing by our broker includes adding value to the alert by cross-matching with legacy catalogs, as well as serving the past history of the alert, meaning the full light curve. For people interested in target and observation manager systems, so TOM systems, there's a TOM toolkit plugin available for ANTARES. And you've heard in Dan Abner's talk yesterday, ANTARES has been fully integrated into this turnkey TOM system built by Gemini NOAA Lab called GOATS. And a unique feature there is users can select and transfer target directly from the ANTARES website to GOATS via the click of a button. Okay, you've also heard about this from Dan yesterday, but just as a quick recap, so very recently, NOAA Lab, in collaboration with Las Cumbres, conducted end-to-end tests for follow-up of Rubin alerts. We did this on 2 consecutive nights back-to-back because we had to demonstrate the robustness of our system. This is the video associated with the press release that came out. It's based on the recording of the 2 nights of the test. You may recognize some of the interfaces here. I won't go into details. But to summarize, ANTARES played a key role in this run. So what took place was we had filters deployed on ANTARES for finding supernova candidates. The filtered alerts were streamed to a Slack workspace, which I was monitoring and vetting in real time to find the targets. So once a suitable candidate a target was found, it was transferred to GOATS, and follow-up was triggered on participating facilities. So we had Gemini North, South, SOAR, Blanco, and Las Cumbres. The runs were done on the nights of February 19 and 20, so a couple of days before the public alert launch of Rubin. But as compared to the 800,000 alerts on February 24th, we were hit with 1 million alerts on the first night of the test and 2 million alerts on the second night. So, but it went successfully, which was very satisfying. We followed up on 18 alerts, obtained spectra for 7 targets. The rest was imaging. And we confirmed various types of supernovae. So you see a type 2 on the screen there. All right, so now I'm going to highlight ways you can interact with ANTARES, and this is in order of simple to complex interaction. First up, you can browse our portal at antares.nualab.edu. If you have internet connection, you can go to this website right away. On the left-hand side of this website, you're going to find all these helper functions that you can use to narrow down the target that you see. That object on the screen was flagged by the filter I wrote for this end-to-end test, by the way. And clearly you can see it's a supernova. You get access to the alert content right on the website as well as the contextual information from the catalog matches, which you can see for this target. So right there, you can see it matched a galaxy from SDSS. All right, okay. Then next up, if you're interested in watch lists, you can upload them directly on our portal and get notification on Slack. And this is how it looks like for my watch list. And these notifications are sent out in real time. We have a Python client library, which you can use to query our alert database. If you're interested in working with the filtered alerts in bulk in real time, then we also have a Python streaming client, which you can use, pretty powerful. And the last bit here, which I think will be most interesting for this crowd and the most complex interaction, is you can develop and contribute science filters to run in real time on ANTARES. And on that note, I'm going to try to do this live. We're going to write and submit a science filter. So let's do this. All right, great. So the first place to start is our portal at antares.nualab.edu. And there, if you go to the FAQ tab, you'll find a link to our dev kit site. So this is the library you'll need to use for filter development. And in this website, you'll find all the detailed instructions for developing and submitting a filter. There has been a major change from the previous version of ANTARES. We have decoupled the dev kit library from Astrodata Lab. What that means is you can do your filter development locally. The Astrodata Lab option is still available if you're interested in using that. You find the example of a real filter and the template of a filter. It's heavily commented, and this is basically more or less what you'll be using once you figure out what your filter needs to do. All the comments will tell you what parameters are required, what are optional, and so on. Once your filter is ready, you have to verify that it runs, it works. So you need to get a target from the ANTARES database. And for that, you have to use the client library, all right? And finally, you're ready to submit the filter. Again, here has been a major change from the previous version. You could do the submission directly on the portal earlier, but that was proving to be very difficult for our developers to maintain. So we have migrated to GitLab. And in here, you find the repository that you will interact with for the filter submission. So this is the DevKit filter, DevKit repo maintained by the Community Science and Data Center of NUALAB. Of course, the catch here is you need to have a GitLab account, but that's kind of straightforward. Here, I want to highlight a couple of things, and that is within this repo, if you go to ANTARES DevKit folder, there you find all these filters that ANTARES is currently running, be it on ZTF or Rubin alerts. So for example, young Rubin transients. So this is the filter I wrote for the end-to-end test that we did. It was very performant. So if you're interested in details, you can take a look here. I also want to highlight another filter that we'll use for this live demo, and this is LSSD DDF. So this was a filter contributed by Asli. What it does is finds any alert in the Rubin deep drilling fields. Very simple, but very powerful. Okay, so now let's go to a notebook. So here we'll do our filter development. It's kind of self-contained. I've installed the main libraries needed, the ANTARES DevKit and the ANTARES client. And now we're gonna import these libraries. And what our filter will do is find the supernova candidates in the Rubin deep drilling fields. And for that, we'll use the output from the two filters that I just highlighted. I've already fetched a target where we will test our filter. So you can see this has been tagged by these two filters, meaning it worked on that, and then this is a supernova. All right, going back. So now let's load the target into our notebook. And now I'm just printing some attributes of the object. So in case you want to inspect the light curve of the target, you get it right there. The tags associated with the object and the ANTARES ID. So ANTARES assigns a unique ID to every object in its database, irrespective of the internal survey ID. Okay. And here is our main filter. So what I did for this is simply modify the template that I showed in the dev kit website. So what will happen is any alert that has these two tags will be processed by this filter. The rest will be skipped. Our output tag will be hot wiring transients, and I included a description and an additional criterion that we provided in 22 meg. Very, very straightforward, simple. And here's the main action happening in the run function. Let's execute that. And now we'll run this filter on the target that we just loaded. And yeah, it worked. Well, it didn't crash, so it worked. Hot wiring transients, so that's the tag that we gave in our filter. So it's great, it got it. So now we're ready to submit the filter. What do? We go back to the devkit repo. I'm gonna try to make it a bit bigger if I can. First step is you will need to fork it. So it's just pressing that button there. I have already done that for this demo. So this is my copy of the upstream in my GitLab account. Second up, you want to launch what is called the Web IDE. This is like a JupyterLab environment associated with GitLab. And then you go to the ANTARES devkit folder, and within the filters subfolder, you'll create a new one. Give it the same as your filter. I think I call it hot wiring demo. And then within this folder, you need to paste your code in a Python file. And that file has to be called init.py. Now we go back to our notebook and just copy paste that thing here. And you see this thing highlighted. So we're ready to commit. So press this button. The developers, request that maybe it's better you commit it in a new branch, giving it the same name as your filter. So it was called hot wiring demo. So I'm going to, sorry. Good catch. Thank you. Okay. You are a lifesaver then. Thank you. All right. Okay. So that's done. And now we're ready to commit or merge, do a merge request. So I'm just refreshing it because you should be able to see the branch that we just created with our new filter in. And then the last step is you create this merge request, give it a name, demo filter, and the last bit, again, here, the developers request you include a brief summary. The template is there in the devkit website, so you can look it up. I've already prepared in advance for this. Copy that in, and then we're going to click this, and we're done. That is all. Thank you.
Questions for Monica with the live demo. Only one typo. It's amazing. Andy. Oh, wait. Do you need a microphone? All the way to the back.
Since filters have to be reviewed, it takes a really long time to turn things around and find bugs and iterate on your filters. And sometimes stuff comes up and we want to change things. We desperately need a way to do this quickly, so that just deploy some filter. I mean, I can imagine several ways. Just let people do whatever, or to have some GUI where you pick choices of things and that's guaranteed to not make malicious code or something. But it's a big problem right now.
We hear you. Yes, so I shared this with Dave yesterday as well. The thing is, our developers are heavily overworked. And so they couldn't find the time to get on the review. But once we get, the fixes to be done sorted out internally, the turnaround time is going to be much faster. Other than that, I mean, if, we have the streaming client, right? So what you can do is, be it in your local system or on Astro Data Lab, you can kind of like simulate or mock up with real alerts, by the way, with your streaming client, and then plug it in your filter, and you can see how it works. That is very effective in catching bugs. I used to do that. But if it is more like, you want to change your threshold for that, yeah, you would have to wait until our developers can get back.
Is that a comment or question? Okay, we will take the rest of that up in discussion. Osley, very quick question. Go ahead. Oh, you need a microphone.
So I know that there is integration into the ANTARES Slack workspace, but I'm wondering if there's any support to integrate into a custom Slack workspace.
Custom Slack workspace. Actually, the end-to-end test, I integrated it to my my personal Slack workspace. So you can do that in your code. Just take a look in my filter. You see the code for it.
Okay. Okay.
Yeah,
Awesome.
you can do that. You can use any Slack workspace. It may not be ANTARES.
Okay. And then is there a way to stream not giving a filter, not giving a tag? Can you stream like a level 1 or like the full stream?
Unfortunately, no. I think it's possible, but L1, certainly we can create a topic and you can subscribe to that, but do you really want L1?
So I guess when you were talking about like testing filter, that was something that I came up with, was like, I can always stream something, but I have to stream someone else's filtered alerts already. And so when I was looking for like more general things, it didn't seem like there was a way that I could just, you could grab one random alert, but or like X number of random alerts, but it wasn't like you could test a stream.
Yeah, that's a good point. Yeah, that application is definitely valid. Yes.
Okay, so let's hold that thought for the other brokers to think about, and thank Monica again.